All right, hey, what's up? Hopefully everyone's having a good weekend. This is the rational exponent homework. I'm only gonna do the evens. There's 40 something questions, so I'm gonna do the even ones. And good luck on the odds. All right, number two. Square root of 16 a squared b to the 10th. So I know that I can take the square root of each individual term. So square root of 16 is going to be 4. A squared will just be a. And b to the 10th, well, 10 divided by 2 is 5. So b to the 5th power. All right, number 4. 64, fifth root of 64. So I have to break this down into its prime numbers, right? 2, 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. So fifth root. So I'm going to take out 5, 3, 4, 5. So there's a 2 left over. So I'm going to pull out a single 2. There's a 2 left over. So fifth root, 2 left over. All right, fifth root of x to the 7. So there's 7 x's. So I'm going to pull out 5 as a single x. And that means that there's 2 x's left over. Likewise for y. I'm going to pull out 5. And there's going to be 4 left over. So pull out a single y. Right, 5 come out as a single. And then there's 4 left over. All right, number 6. 64. Square root of 64 is 8. That's nice. And then how many 2's can we pull out? How many pairs can we pull out of 7? There's going to be 3 with 1 left over. And then y to the 9th will be 4 with 1 left over. So this is going to be 8 x cubed y to the 4th with an x and a y left behind. All right, 8. Number 8 is interesting. Because we're gonna have an exponent in the denominator, right? Or we're gonna have a radical in the denominator. So cube root of 27, right? 27 is 3 times 3 times 3. So I can pull out a single 3. And then what's left over? It's gonna be basically x to the 2/3 power in the denominator. Okay, well, we don't want that in the denominator, right? So we're going to multiply by x to the 1/3 power, because when you multiply common bases, you add the exponents, and the exponents will add to 1. So top and bottom will be multiplied by x to the 1/3 power. So this is going to be, the bottom's just going to be x by design, and then the top we have x to the 1/3 power. So answer 3 cubed root of x over x. All right, number 10. Express using a rational exponent. So this is the fifth root of x squared. So the root is 5 and the power is 2. So roots grow underground. I know I said that a bunch. So 2 over 5. Number 12. 25 to the 1/2 power. 1/2 power is basically square root. So the square root of 25 is just 5. Okay, number 14. Negative 27 to the 1/3 power. So here, notice that the 27 is to the 1/3 power and not the negative. So if you compare quickly, 14 to 19, one is inside the parentheses and one is not. It's a very big deal. For instance, on 14, the 1/3 power is only going to apply to the number, and on 19, the exponent is going to apply to the negative and the 27 simultaneously, I guess. So let's look at number 14. 14 is saying that negative 1 times the cubed root of 27. And we already know, at least by now, that the cubed root of 27 is going to be 3. So this is basically negative 1 times 3, which is negative 3. All right, number 16. Again, this is the same situation where the negative never sees the rational exponent, right? So this is going to be negative 1 times whatever this is, 64 to the 3/2 power. So this is going to be negative 1 times, so remember the root, so it's a square root because the denominator is a 2. So this is the square root of 64 cubed. Square root of 64 is just 8. 8 cubed, 8 times 8 is 64. 64 times 8, so 32, 48, 49, 50, 51, 5, 12. So this is going to be negative 5, 12. All right, number 18. 4 to the 5/2 power. So 4, so the denominator is a 2, so square root to the 5th power. So this is going to be, square root of 4 is 2, so 2 to the 5th power. So 2 essentially times 2 5 times. This is 4 times 2. So 8 times 2 is 16. This is going to be 4 times 4 is 16 times 2 is 32. Okay, number 20. We have negative 64 inside the parentheses, and the 2/3 is going to be applied to all of that, right? The rational exponent is going to be applied to everything. So this means the cubed root, right? Because the bottom number is a 3, 64, and this is going to be squared. Okay, so the cubed root of 64. If you don't know by now, we can always rationalize it. 2 times 32, 2 and 16, 2 and 8, 2 and 4, and then 2 and 2. So we want to group them in threes, right? Because it's a cubed root. So here's 1, here's 2. So the cubed root is going to be 2 times 2, which is 4. So 4, right? That's the inside part, but it's negative, right? It's negative. So these are all going to be negative, which means we're going to pull out a negative 2 and a negative 2. Negative 2 times negative 2 is going to be positive 4. And that's the inside part. And that's going to be squared. So 4 times 4, or 4 squared, is really 16. All right, number 22. Negative 8 to the negative 5/3 power. Okay, so first off, the negative exponent, we don't like that. So that's going to force the negative 8 to go in the denominator. And then we have a positive 5/3. Then, so let's just, right, I can take 5/3 power top and bottom, right? I can do this to top and bottom. Top is nice because it's just 1, so I know it's going to be 1. However, the denominator is going to be, so the cubed root of negative 8 to the 5th power. Cubed root of 8 is 2. All right, 2 times 2 is 4 times 2 is 8. So it's going to be 2. Because it's negative, it's going to be negative 2. So negative 2 to the 5th power. It's an odd number. It's going to be negative 32. So 2 to the 5th power is 32. All right, 24. 25th to the negative 5/2. Again, the negative exponent, we don't like that. That's going to force the 25 to go to the denominator, and it's going to be raised to the 5/2 power. The numerator is 1, which is nice, so that's just going to be 1. However, the denominator, square root, right, because it's a 2, to the 5th power. So square root of 25 is 5, 5 to the 5th power. So 5 times 5 times 5 times 5 times 5. All right, 25 times 625, I believe, times 5. So 625 times 5, 25, 10, 12, 31. So 1 over 3125. All right, number 26. So this one definitely gets a little bit more interesting. The numerator is not 1 now, so this is a good example. So I'm going to take the cubed root of the top squared over cubed root of the denominator squared. Okay, cubed root of 27 is just 3. And then 3 squared is 9. The cubed root of 8 is 2. 2 squared is 4. So here, knowing the cubed roots really helps out. Otherwise, you'd have to see that, okay, 27 is 3 times 3 times 3. And then we can circle, pull out 3 3s. And then the same with 8, right? 2 times 2 times 2. And then square them in the end. All right, 28 is interesting. The negative is going to turn, or is going to flip 27 over 8, which is it basically the problem we just did. So 9 over 4. That's nice. It's nice when that happens. Okay, number 30. So I guess the question comes up, do you have to flip the number first, right? Like dealing with this negative. I mean, technically, right? Like if you're nice, like watch. So if you don't flip it first, you're gonna have to flip it at some point. So I know that I'm gonna have to take the square root of 16 and cube it, right? Because this is the root and then this is the power. Now, at some point, I'm gonna have to flip it and it's gonna be in the denominator, but we could disregard that for just a moment. Square root of 16 is 4. 4 cubed. 4 times 4 is 16 times 4. So 24. So 64. So this is going to be 64. But because it's negative, the exponent, we'll have to use the reciprocal. So 1 over 64. All right, 32. 1/9. All right, so 3 halves. So 9, square root of 9, cubed over 1. Right, 1 to the 3 halves power is just 1. So what's the square root of 9? 3. And 3 times 3, 27. So 1 over 27. Number 34. The cubed root of 4 to the 6th power. Cubed root of 4, that's not a nice number. It doesn't work out cleanly. So the next best thing we have is to turn it to an exponent and then see if it'll simplify somehow. All right, number 34. The cubed root of 4 to the 6th power. Cubed root of 4 is not a clean number. It's not a whole number, right? It's irrational. So the best option that we have is to convert it to an exponent and then see if it can simplify. If you have a power raised to a power, we know we multiply the exponent. So this is going to be 6 over 3, which is basically 2. So 4 squared is going to be 16. All right, number 36. Exact same idea. So 5 to the 1/4 power, right, because it's the 4th root, raised to the 8th power. Multiply the exponent, so you're going to get 5, 8 over 4, which is basically 2. So 5 squared is 25. I mean, it really helps knowing the exponent properties for sure. All right, 38. So we have a power raised to a power, so we're going to multiply. So this is going to be 27 negative 4 over 12, which is basically 27 negative 1/3, right? Because this simplifies to 1 over 3. Okay, this is actually nice because the negative is going to force the 27 in the bottom, and we're going to take the cubed root of 27. And by now we know that the cubed root of 27 is 3. All right, number 40. In parentheses, 27 2/3 power minus 27 to the 1/3 power, all squared. So before we square anything, let's try to simplify the inside part. So this is going to be 27 cubed root squared minus 27 cubed root. And all of this is going to be squared. So cubed root of 27 is 3. We come across that quite a bit. And here we have 3 squared, so this is going to be 9. So 9 minus 3 squared. So 9 minus 3 is 6. Squared would be 36. All right, here we are. Last problem. All right, number 44. A cubed times a to the 2x plus 9 equals a to the 5x minus 9. So when we multiply common bases, we can add the exponents. So 3 plus 2x plus 9, and this is equal to a 5x minus 9. All right, 3 plus 9, 12. So a 2x plus 12 is equal to a 5x minus 9. Okay, we can set the exponents equal to each other. So this is going to be 2x plus 12 is equal to 5x minus 9. One variable problem, right? So minus 2x from both sides, minus 2x. I'm going to add 9. Add 9. This is going to be positive 21 is equal to 3x. Divide both sides by 3. X is equal to 7. Okay. The odd number problems that we just did, I feel are sufficient for you to, if you can follow along with what I did, get comfortable doing these calculations on your own and try to apply them to the odd number problems. Have a good rest of your weekend.